Hey everyone, you've seen that picture, right? The iconic blue marble. It's this image of Earth as a perfect, beautiful sphere floating in space. But you know what? That stunning picture is hiding a fascinating secret. What if I told you the Earth isn't a perfect sphere at all? And what if that subtle imperfection is the very thing that drives our climate, changes the force of gravity, and, makes life as we know it possible?
So if it's not a perfect sphere, then what exactly is our planet's true shape? Let's go beyond that simple image and find out.
Okay, so the technical term is an oblate spheroid. Now that might sound really complicated, but the idea is actually super simple. Just picture gently squishing a rubber ball. The top and bottom flatten out a little bit, and the middle part pushes out. That's our Earth, in a nutshell. It's basically a slightly squashed ball. And this isn't just a theory. We can actually measure it. The diameter at the equator, its widest part, is about 12,756 kilometers. But if you measure it pole to pole from north to south, it's a little shorter, coming in at about 12,714 kilometers.
So what that means is our planet is about 43 kilometers, or almost 27 miles wider than it is tall. Now, on a planetary scale, that's a tiny difference, which is exactly why it still looks perfectly round from space. But, as we're about to see, that small imperfection changes absolutely everything.
So you have to wonder, what incredible force could be powerful enough to physically reshape an entire planet? Let's find out.
It all comes down to the Earth's daily spin. As our planet rotates, it creates an outward push called centrifugal force. This force is way stronger at the equator, where the spin is fastest, and over billions of years it has caused all the rock and magma there to bulge outwards. Meanwhile, up at the poles, where the spin is super slow, the planet has basically flattened in response.
The best analogy for this is a chef spinning pizza dough. You've seen that, right? The faster they spin it, the more the center just spreads out and flattens. The same exact physics that shapes a pizza also shaped our world, just on a mind-bogglingly bigger scale.
Now, while today we have satellites that give us the ultimate proof, people actually knew the Earth was round for thousands of years. They didn't need to go to space, they just had to look around and observe. And their observations really set the stage for understanding all these finer details. They saw that a ship sailing away disappears from the bottom up. The hull vanishes over the horizon before the mast does. During a lunar eclipse, they noticed the Earth's shadow on the moon is always a perfect circle, and only a sphere can cast a shadow like that. And even the simple fact that the sun rises in Tokyo hours before it sets in Los Angeles, that was a massive clue. These classic proofs are just a testament to brilliant human observation.
Okay, so the Earth is a slightly squashed, spinning ball. Why does any of this actually matter? Well, this is where it gets really interesting, because this shape has massive, real-world consequences.
First off, our planet's curve is the engine of our climate. At the equator, which bulges out toward the sun, sunlight hits directly. It concentrates all its energy, and bam, you get hot, tropical climates. But at the flattened poles, that same sunlight arrives at a really low, glancing angle. It spreads its energy thin, and that creates the frigid conditions we see there. The very existence of both rainforests and glaciers is a direct result of this curve.
Okay, now for a fun one that might surprise you. True or false, you would literally weigh less standing on the equator than you would at the North Pole. What do you think?
It is absolutely true. Gravity is not a constant force on our planet, and there are two big reasons for this. First, because of that equatorial bulge, you're physically farther from the Earth's center of mass, which slightly weakens gravity's pull. And second, that powerful centrifugal force from the spin is strongest at the equator, and it's literally pushing you outwards just a tiny bit, which counteracts gravity.
This means gravity's pull is weakest right where the Earth is widest at the equator and it's strongest at the poles. And while you might not be able to feel it yourself, this difference is significant enough to affect massive systems, like our ocean currents. It's even something engineers have to account for when they're launching rockets into orbit.
And finally, our entire modern world is built on this geometry. The grid of latitude and longitude that lets us pinpoint any location on the globe, it only works on a sphere. Our system of time zones, and the great circle routes that planes use for efficient travel, all of it is fundamentally based on the simple fact that we live on a predictably curved planet.
So let's bring this all together. The Earth isn't just some static rock. It's a dynamic system, and its imperfect shape is a direct result of its constant motion. When it comes down to it, our planet's imperfection isn't a flaw at all.
It's the key feature that makes life possible. That slight bulge is what drives our diverse climates, it varies the force of gravity, and it's what makes our world the dynamic, habitable place we get to call home. It's a great reminder that sometimes the most fascinating truths are hiding just beneath the surface of what we think we know. It really makes you wonder, what other simple facts about our world are just waiting to reveal a deeper, more complex story?